Hello friends, welcome to today's machine learning class, and in this class we will see another important topic from first unit, that is artificial neural network. And today let us see the introduction about artificial neural network. The artificial neural network is otherwise called as ANN, which is inspired by the working of human brain, right? Okay, the human brain is having more number of neurons that will be interconnected to each other to pass the information between the neurons. Okay, like the same, the artificial neural network also having more number of neurons, which is otherwise called as nodes. Okay, here all the nodes will be interconnected to each other. Now what is the purpose of artificial neural network? That is used to recognize the patterns, relationship and information from the data. That is, the data is actually very huge volume of data. From the huge volume of data, we need to recognize the patterns, relationship and information among the data, right? And the process which is inspired by working like a human brain. This is important. Okay, artificial neural network will work like the human brain, and this is the sample diagram for a human brain. This is having the dendrite. The dendrite will accept the information from the another neuron, and this is the cell nucleus. So this one is the cell nucleus. All the computations will be done in this cell nucleus, and axons is the output information. Okay, that is coming from this cellulus, and this is the synapse. Then this is like the weightage of input. That is, we are giving some additional weight to the input, okay, to pass the information from one cell nucleus to another cell nucleus. And now let us see how the artificial neural network will be related to the biological neural network. Okay, that is the relationship between BNN and ANN, right? So here in biological neural network we are having dendrites, and that is same as input in the ANN. See, this is the artificial neural network. Here we are having two input nodes. Okay, cell nucleus is same as the nodes in the artificial neural network. So here we are having 2, 3, 4, 5, 6, 7. So totally 7 nodes will be there in this network. Okay, so which is exactly similar like the cell nucleus in the biological neural network. And next one is synapse, and synapse here, that is equivalent to weight in the artificial neural network. So for every input, the green nodes are input nodes. Input, we need to add weight. Okay, and next one is axion. So this is the axions, and that is exactly similar like the output. The purple color node is called as the output node. Okay, we will get the output in this output node. Okay, now let us see the components of artificial neural network. Okay, so a very simple artificial neural network which consists of three components. What are the three components? First one is input layer, hidden layer and output layer. Okay, first one is input layer, second one is hidden layer, and third one is output layer. The hidden layer is otherwise called as middle layer. Okay, so for every artificial neural network, input layers will be there. Through the input layer we will accept the input. Okay, for example x1, x2. x1, x2 are called as inputs, and that will be given to the input layer, and the hidden layers are there. All the computations will be taken place in the hidden layer, and finally we will get the output from the output layer. Okay, in the output layer we are having one node, right? And now let us see all the layers in detail. The first one is input layer, which accepts the input or information from the outside world. Okay, that is the input layer. In the input layer we are having more number of nodes. And the second layer is hidden layer, and in the hidden layer we are having a set of neurons where all the computations will be performed on the input data. Okay, the input data is given from the input layer and that will be passed to the hidden layer, and all the computations will be performed on the hidden layer only, and there can be many number of hidden layers in the neural network, and the simplest network which consists of at least one single hidden layer, at least one hidden layer will be there. And the last one is output layer. In the output layer which will give the output of this process, okay, which is derived from the computations of the hidden layer, computations from the hidden layer, okay, and there can be a single or multiple nodes in the output layer. The output layer consists of one node or more number of nodes, okay. So if the classification is binary classification, then the output node will be only one. If the classification is multi-class classification, then the output node will be more than one, okay, more than one output node will be there, okay. Another important concept from artificial neural network is perceptron, okay. Perceptron is nothing but the very simple form of neural network which consists of single layer where all the mathematical computations are performed. So this is important, okay. Perceptron is nothing but a simple form of neural network which consists of a single layer. In this single layer all the mathematical computations will be performed, okay. So this is a very simple diagram for perceptron. Here we are having three inputs, x1, x2 and x3, okay. Three inputs will be there. For all the input we need to add the weight. So after adding weight, x1 w1, x2 multiplied by w2 and x3 multiplied by w3 will be given to this neuron, okay. The neuron will add all these things and finally it will produce the output, okay. So this is the very simple form of perceptron. The next one is multi-layer perceptron, which is otherwise called as the artificial neural network, okay. Multi-layer perceptron is the artificial neural network which consists of more number of perceptions which is grouped together to form the multi-layer neural network, okay. Just to see this diagram here, this is the input layer. In the input layer we are having totally 6 nodes will be there, 1 2 3 4 5 6, totally 6 nodes are there in the input layer, and second one is 2 hidden layers will be there. In both the 2 hidden layers 4 nodes are there. In the first layer we are having 4 nodes and second layer also we are having 4 nodes, okay. In the second layer we are having 4 hidden nodes will be there, and also we are having only one output node, okay. This is the output node that will come under output layer. This is multi-layer perceptron, which is actually the artificial neural network. And now let us see the working of artificial neural network, right. So here we are having n number of input units, x1, x2, x3 etc. up to xn. So these are all called as input unit, and all the input units having its own weight, okay. So after multiplying this weight with x1, the data will be x1 into w1 will be there. So here x2 into w2, x3 into w3, and like the same xn into wn is there, okay. And all this data will be summed by using the summer unit, okay. Here summation of y equal to 1 to n xi into wi is there. After adding all these things, you need to include the bias also, okay. Bias will be added finally. So this is called a summer unit. Summer unit is used to sum all the input data along with their weights plus this bias, and this will be given to the threshold unit. Here we are having sigmoid function, the data will be 0 to 1, some very minimum value, okay. We need to test the output of this particular unit, that is that will be y cap, y hat. Okay, y hat will be compared with the original output, that is y. Okay, if there is any deviation, what we have to do? We have to adjust this weight, and all this process will be repeated one more time. Okay, until y hat which is equal to y. Then finally that is the output. And this is the computations performed in hidden layers, which are done in two steps. Okay, the first step, all the inputs are multiplied by their own weights. Okay, here we are having x1 to xn, all the input layers and all the input values will be multiplied by its own corresponding weights. Okay, this is the first step. Okay, weight is nothing but the gradient or coefficient of each variable, that is x value, and this shows, that is the weight shows the strength of the particular input. Okay, so after assigning the weights, the bias variable will also be added here. See, bias will be there. Okay, bias is nothing but a constant value which helps the model to fit the best way possible. Okay, finally the output of summer is Z1, which is equal to W1 x1, W2 x2, etc. up to Wn xn plus B. B is nothing but bias, that is the constant value. Here W1 to Wn are the weights which are assigned to the inputs x1 to xn, as well as the B is added finally. The next step is the activation function that will be applied to the linear equation Z1. We have already know what is the linear equation. We have computed from the summer unit, isn't it? Z1 equal to W1 x1 plus W2 x2 etc. up to Wn xn plus bias. Bias is nothing but a constant value. Okay, and the activation function will be applied to this Z1, and this is nothing but a non-linear transformation of the linear equation which is applied to the input before sending this input to the next layer of neurons. And next the computation result will be passed from hidden layer to the last layer. Which is our last layer? Last layer is nothing but the output layer, isn't it? So output layer that will give the final output. Okay, the process explained above is known as forward propagation. That means from the input layer we are passing the data to the hidden layer. From the hidden layer all the data will be passed to another hidden layer, and finally we will get the final result from the output layer, isn't it? So the data will be passed from the input layer to the output layer. This is called as forward propagation. So after getting the prediction, that is the predicted output from the output layer, the error is calculated. The error is calculated. So first we need to compute the output. In the first iteration we will get the y hat, and the y hat will be compared with the actual, that is the actual output. The difference between the actual and predicted output is called as error. Okay, the difference between the actual output and predicted output is called as error. If the error is large, then what we have to do? The steps are taken to minimize the error for the same purpose from the output layer to the input layer. That will goes to the backward propagation. Okay, backward direction, which is called as backward propagation, is performed. Okay, now let us see what is back propagation. Okay, it is a process of updating and finding the optimal values of weights or the coefficients, okay, which will helps to minimize the error. This is important. Okay, what is error? Error is nothing but the difference between actual output and the predicted output. Okay, here how the weights are updated and new weights are calculated by using the optimizer. That is, by using the optimizer we can update the weights, and optimizer are the methods or the mathematical formulations to change the attributes of neural networks, that is weights to minimize the error. We have to adjust the weights in all the nodes so that we can minimize the error. This is called as backpropagation. And next let us see the characteristics of backpropagation algorithm. Okay, the first one is instances are represented by many attribute value pairs. Instances are nothing but the training samples. Instances are training samples. All the training samples are having its own attribute value pairs, and this will be given to input to our network. Okay, and the value is normally real values, right? And next one is the target function, which is actually the output, and the output value will be the discrete value, real value, or the vector of several real or discrete valued attributes. Okay, this is the target function. And next one is the training example may contain errors, because the data is actually very huge volume, and the training samples will be taken randomly from this huge volume of data. So obviously errors may be included in this training sample. And the next one is long training times are acceptable. So based on the number of input data and the corresponding weight for all the input data, sometimes it requires long time to train the model. Okay, so it may be extended to few hours. And the next one is fast evaluation of learned target function may be required. Okay, so fast evaluation is very much required in this artificial neural network model. And the last one is the ability of human to understand the learned target function is not important. This is not important for human to understand all the target functions. Okay, so these are the characteristics of backpropagation algorithm. Up to this we have seen only the introduction to artificial neural network, and in the next class we will see some more detail about artificial neural network, especially the backpropagation algorithm. Thank you.